So with these, we have to simplify each radical. And simplify, we always have to see what's the largest perfect square that can go into each number. But always first check and see, is the number a perfect square? So take a look at number 6. 24 is not a perfect square, so we have to see how we can simplify it by figuring out what the largest perfect square that can go into 24. And the largest perfect square that can divide evenly into 24 is 4. And they can divide into it 6 times. Then we take the square root of the perfect square. The square root of 4 is 2. Can't take the square root of 6, so we tack it on. And we are done. If we take a look at number 7, I notice I have a negative underneath my radical. Whenever that happens, we have to take out an I, and then the number underneath the radical becomes positive. And then we have to simplify that number. 242 is not a perfect square, so we have to figure out what's the largest perfect square that can go into 242. And I have a coefficient, so I have to put my parentheses. Well, the largest perfect square that can divide into 242 is 121, and you can go in there 2 times. You might have to play around, you might have to make a list of perfect squares to figure that one out. So then we take the square root. Okay, so now we have to take the square root. Square root of 121 is 11. Can't take the square root of 2, so we tack it on. And then we have to multiply our coefficient. So then we have to do I times 11, which is 11I, tack on the radical 2. And we are done. That is our answer for that one. If we take a look at the next problem, same kind of thing with 8. We have a negative underneath the radical, so we have to take out an I. Okay? And then the number underneath the radical becomes positive. 56 is not a perfect square, so you have to simplify it. We have a coefficient, so we have to put parentheses around it. Okay? And then we have to figure out what's the largest perfect square that can go into 56, and that is 4. Okay? And 4 can go into 56 14 times. So we get negative 3I times square root of 4 is 2, tack on the radical 14. And then our final step, again multiply, negative 3I times 2 is negative 6I, tack on the radical 14. And number 9, we have a fraction. And when we ever have a fraction, we can separate it and give each number its own home, its own radical. Then go through and see how can I simplify each of my radicals. So I take a look at 8. It's not a perfect square, but I can still simplify it. Okay. The largest perfect square that can go into 8 is 4, and it can go into 8 2 times. Square root of 4 is 2. Can't take the square root of 2, so we tack it on. Okay? So that becomes 2 radical 2. In the bottom, 36 is a perfect square, and the square root of 36 is 6. There's no more radical around the 6 because it's a perfect square. Then our next step is simplify the fraction if we can. We have 2 over 6, and 2 over 6 simplifies down to 1/3, but we still have that radical 2 in the top. And we are done. If we take a look at number 10 is really similar to number 6. 150 is not a perfect square, so we have to simplify it. And we have to figure out the largest perfect square that can go into 150, and that is 25. Okay? 150 can go into 25 6 times. The square root of 25 is 5. Can't take the square root of 6. Tack it on. And there's our answer. And then this last one, again, we have individual, we have a fraction, so we can split it up into each radical. So when we simplify, We have a negative underneath the top radical, so we take out an I, and that 4 becomes positive, and then that stays radical 9. Okay? Then simplify each radical. I notice in the top the square root of 4 is 2. Don't forget to tack on the I with the 2, and the square root of 9 is 3. Can't simplify 2 over 3, so we just leave it as 2/3 with the I, and we are done.